Now for Dr. Robert Kirstein. Thank you very much. So Dr. Kirstein received his DMD degree in 1983 and his prosthodontic certificate in 1985, both from Tufts University School of Dental Medicine. From 1985 to 1998, he maintained an active appointment at Tufts as a clinical professor teaching fixed and removable prosthodontics. Since 1984, Dr. Kirstein has been at the forefront of T-scan technology, studying its earliest form and advancing his knowledge of the system as it evolved into its current iteration, the T-scan Novus version 10. Over the past 40 years, Dr. Kirstein has published many original research studies using all versions of the T-scan, which has led to his becoming the leading authority and researcher in the field of digital occlusal analysis. In addition to what you see listed on the screen, Dr. Kirstein has edited 9 research volumes covering all the known applications of the T-scan occlusal analysis technology. And you'll see the latest volume handbook is listed on the screen there with a link where it can be ordered with a discount code. And we can also provide that for you after the webinar. So a pioneer and academic science advocate for digital occlusal technology, Dr. Kirstein teaches a measured system which greatly improves the success of bite-related procedures, commonplace in every dental practice. Well, I will now turn it over to Dr. Kirstein and welcome everyone.
Well, thank you very much, Diana, for that introduction, and thank you to TechScan for hosting this webinar on complications in implant dentistry. So before I get into complications, I will talk about what's available, digital occlusal technology systems to all of you, and then how they can be applied in clinical practice. The opinions expressed tonight are mine and not those of TechScan. And I have no financial relationship with any dental company. I do not receive compensation for sales of any dental product shown in the presentation. And as I said, the opinions are mine and not those of TechScan, our very nice sponsor. So let's get into it. What are the available digital occlusal technology systems that you can use in your day-to-day practice? Well, of course, the T-scan 10 Novus, which is the newest version of T-scan, it has 40 years of system evolution behind it. And I began using it in 1984. And it measures 256 relative occlusal force levels. It shows them to you in colors. And they're recorded in a dynamic way in 0.003 of a second video framing. And it allows you to see incredible detail into the occlusion, which we'll obviously show you in this seminar. Then a more recent introductive technology is the OccluSense 1 by Bausch from Germany. It's about 5 years old. It also shows 256 relative occlusal force levels, but it captures them in a much slower rate, in a half a second. And it marks the teeth similar to articulating paper. So the sensor has ink on it that marks teeth while you record, which may or may not be an advantage, which is something that you'd have to sort of test out for yourself. Then there's a product that's only available in South Korea. It's not really available anywhere else in the world. It's Accura. It's called Accura 1. It's about 5 years old also. It records 256 relative occlusal force levels, but in only 100th of a second. And just to show you how far we've come with T-scan, when T-scan 1 was first built, it recorded in 100th of a second. Now we record in 0.003 of a second. So a major advance. So Accura is more of a mimic of T-scan in its own right, and its desktop looks a lot like T-scan, so it's more of a copycat technology. But it's not available to you to purchase in this country. So it's not really a player that you would become involved with. Then we have scanners, and I'm sure many of you own scanners. And scanners are kind of a wonderful advance for making impressions, but they're not an occlusal force advance in any way because they don't record occlusal force levels despite what the scanning companies want you to possibly believe. And we'll talk about that in great detail a little bit further down the road in the presentation. They do not record occlusal force levels, and only one system records contact timing and motion, and that's maw-jaw, which is extraoral sort of video capture of mandibular motion. And finally, we have InnoBite from Koubei in Canada, which is about 4 years old. And it's actually a very nice technology. It reports absolute force or real force numbers, which you can see on the display. There's a digital display showing 475 newtons. It reports in newtons. And in simple terms, the patient bites on this silicone pad with strength, and then you get a readout of their capability. And so you get a numeric assessment of their bite strength. And human bite strength ranges from like 0 to 5 to 700 newtons. Extreme bite force might be 800 to 900 newtons. So, this example is showing median human bite force, a little bit more than median human bite force. But the real question is, which one of these is best for you, the dentist, to use to treat patients? So initially, I showed you them all. Well, InnoBite, you really can't treat patients with. You can only monitor success or failure in improving someone's bite strength. For example, in this study, which the T-scan was used to treat patients' occlusions after the patients were initially recorded with InnoBite, T-scan was then used, and then the same patient was recorded again in the same visit with InnoBite, and the group of subjects, about 30 to 40 subjects, after having T-scan, all their, as a group, they're statistically increased in bite strength. And so InnoBite can be used to monitor those kinds of improvements or negative responses, like having weaker bite strength. But it can't really treat patients in any way. It can't treat the occlusion, tell you which contact is a problem or what part of the mouth is a problem. So InnoBite really isn't for treating patients. Then we have scanners. Well, scanners, these occlusograms, you can't treat patients with either. They may help you design crowns, they may help you design restorations, but you're going to learn a little bit more about scanners. These color-coded representations are not force, they're contact proximity. In other words, closeness of how closely teeth touch. But whether the teeth touch well or touch slightly far apart or touch very far apart doesn't translate into being able to recognize what parts of the teeth should be adjusted and how much they should be adjusted. So scanners really can't treat patients either. So that leaves you T-Scan 10 Novus and OcluSense 1 from Bausch, which have distinctly different price points. You can see the T-Scan Novus is about $11,000 US, and the OcluSense 1 is about $4,500 US. But there's a significantly different value, which you're going to come to learn, not only in the technical capabilities, but also in the usability of the two products. So first, it's important that you understand T-scan sensors, which are mylar encased and hold up very well to repeated intercuspations. They can be used about 24 times without cracking, and they cost about $10 per sensor. And because they're encased in mylar, they can be cleaned and reused with the same patient. So if I made 3 recordings in a consultation on someone and the patient decided to come back for treatment, I could reuse that sensor another 21 times, right? So that's really a valuable thing because the sensors can be reused if needed, within limits. If you used it 20 times on someone, you don't want to reuse it. But certainly it's has a very good lifespan, and it holds up very well to intercuspation. OcluSense sensors, on the other hand, cost about $16 per sensor, and they only last for 5 to 7 intercuspations. They're not very strong. They don't hold up well to intercuspation. They perforate readily, which was determined in this individual assessment of the two technologies written by Dr. Sutter, which he published in 2019. He found repeatedly that that the OcluSense sensors didn't hold up well, and they had to be changed because when you have a broken sensor, electronic sensor, as these types of sensors are, you get a corrupted output, and you get basically a break in the circuitry. So the other thing about OcluSense sensors, which is they can't be reused because they're surrounded by cardboard, and of course the ink smears off once you start biting on it. But the cardboard can't be sterilized, it can't be alcoholed off, it can't be reused. So these have much shorter lifespan. Now, in terms of their accuracy, an independent study done by this group in Spain, which was published in 2023, found that the T-scan was able to reproduce the 256 force levels with very low variation, which means they basically produced linear force reproduction in multiple contacts on the screen or on the test casts, which I'll show you what that means in a second. Whereas OccluSense had a high level of reporting variation, 12%, compared to 0.8%, which means that T-scan was 15 times more accurate. And that means a lot when you're treating someone and you're recording on them a number of times in a single session. You want linear force reproduction, right? No matter how many times the sensor is crushed. So what's interesting about this new study is it actually replicated this study published in 2006 that I was a part of, that showed that the the HD sensor, which is the Generation 5 sensor that we use today, tested in 2006 in this handle, this T-scan evolution handle, produced linear force reproduction across 6 or 7 contacts with repeated crushing. And this was tested with 30 or 40 sensors. And so this is exactly what this group in this paper in 2023 actually found, was this very low variation after repeated crushing, which is, again, really important when you repeatedly record on people. You want to get accurate, reproducible force data. Now, something that these technical things are important to show you some of the differences. OccluSense, although it represents 256 levels of force, it only uses a 4-color scheme, which means each color represents 64 force levels. So the difference between what is green tall or green small or red tall or red small is very hard to discern. And it makes it impossible to fine-tune subtle contact changes because there aren't enough force levels per color. There's too many. Whereas T-scan, you have 18 colors and you have 14 force levels per color. And this is 4 times more broken up, essentially, or 5 times more broken up, which means that you can readily fine-tune the difference, for example, between those 2 contacts and that contact. And the columns are only 1 height per color. So you don't have tall pinks and small pinks. You have tall pinks and tall reds and oranges for high force. You have orange, yellow, light green, aquamarine for medium force, and you have blue and dark blue and very dark blue for low force. And you can see the scale here. So there's no confusion. This is very confusing. What is the similarity between these 2 colors? Why is one small? Why is one tall? And then you have another issue, which is the OccluSense arch is generic. It has no tooth delineations. So where is this area? On what part of the tooth is all of this force? And what do you adjust? And where is it? Is it on the mesial-modular ridge? Is it on the lingual surface? Is it on the buccal surface? I mean, we can make generalizations, but it's not accurate in any way. Whereas T-scan data is very clear where it is. You can actually incorporate an STL file and overlay the STL file with the force data. And for example, in this case, if we wanted to adjust this high force on this overloaded implant, we know we're dealing with the mesio-buccal cusp. It's very clear what needs to be adjusted with T-scan. This is far more diffuse. And although these are technical issues, there is a significant main issue that all of you who are contemplating getting into digital occlusion and possibly purchasing one of these 2 systems, the most important difference between the 2 systems is not a technical one. It's not a mechanical one. It's this one. T-scan data is extremely well understood. So we can teach you. You can learn how to use its data to treat occlusal problems in many known clinical applications. As Diana was introducing the 4-volume encyclopedia handbook, this T-scan in orthodontics, T-scan in prosthodontics, T-scan in implants, T-scan in TMD, T-scan in posture, T-scan in general occlusion. We have applications and proven protocols in many, many, many disciplines in dentistry that you come across every day in your practice. Whereas OccluSense data is not understood at all. It's not T-scan. This is not T-scan data. And why some of these red columns are this tall and some are only this tall and this orange one is as tall as this red one, someone has to figure that out, what all that means. But as of now, no one knows what that means. It has not been through rigorous testing and protocols haven't been developed, which means you can't use it with any known accuracy in any dental clinical application. And that's actually a real issue. So in that way, OccluSense 1 is very much like T-Scan was. T-Scan 1 was 40 years ago. This is T-Scan 1. This is what I started with, carrying around Tufts Dental School, studying dental students. Unless there's someone like me who wants to figure out OccluSense 1, a typical OccluSense user is on their own. You would have to be like me. You'd have to figure out what all this means in the OccluSense world. And unless you're willing to do that, you're not going to be able to use it effectively on patients. And that means someone who purchases it isn't going to be able to use it effectively on patients. You may think using effectively on patients, but it has no known protocols. So that's the huge value difference between the two technologies. T-Scan, you can learn to use it and treat a lot of things, right? So why do I recommend that doctors use the T-Scan 10? Exactly what I was talking about. 40 years of product iteration, multiple generations of sensors. This is the 5th generation of sensor. The HD Novus sensor is highly reproducible, highly accurate, and other hardware and software system accuracy improvements have been made along the way, right? And importantly, there are over 400 papers in the literature substantiating its clinical efficacy in multiple dental disciplines. This paper by Dr. Chowdhury below is actually goes through, is a systematic review that goes through all of the things that the T-Scan does and has been tested in research environments, in studies with metrics and data and statistics. So what that means is there are multiple clinical protocols that have already been developed, tested, and validated effective with patients that you can learn to use to treat patients with, right? So all you have to do is learn how to use it effectively, which is a learning curve, no question, but the protocols exist for how you use it with Invisalign, or how you use it with an all-on-4 case. And so this is a huge advantage over OccluSense 1. There are no proven clinical protocols, and there are no tested, validated methodologies as of yet. So T-Scan is ready to go if you feel it's something you'd like to get involved with. Now, something you may not realize is TechScan sensors are used all over the world in multiple industries because of their force, time, and pressure mapping accuracy. These are just a few of the systems that there are in the mechanical world. This is a brake pad system that allows the brake pads to wear more evenly by studying how the brake pads rub up against the wheel housing. This is an engine gasket seal system for pistons and cylinders. This is a system that measures wrist pressure during driving so that steering wheels can have their arc optimized to minimize damage to your wrist when you're driving. This is a foot product, the F-scan. This allows people to measure gait analysis and pressure. And you can see here's an example of the data of the F-scan, and it's very similar, right? It's color coded in the same way: low force, moderate force, high force. You see this pad, the heel of this foot is under extreme pressure, so a shoe can be modified, a orthotic can be made. Interesting. I'm a golfer. Many of you who know me, I'm a golfer. I watch the Golf Channel a lot. You can see this is the Golf Channel on TV. They were demonstrating the TechScan sensors inside golf shoes being used to show how they can help a golfer redistribute their foot pressures during swinging. If they get too far out on their toes or they get too far out on the sides of their feet, they can learn to modify their foot pressures and have a better grounding to be able to hit the ball better. And this is just one real world application of the same thing that you can use in someone's mouth to optimize their teeth. So what TechScan sensors are really good at is making sure that surfaces that mate, mill, mesh, bang into each other, rub up against each other, don't destroy each other, right? That's what teeth need to do, is rub up against each other and not destroy each other. So you can bring these highly evolved engineering sensors to your practice and help your patients, with their occlusions in far more sophisticated ways than traditional occlusion, non-digital occlusion offers your patients. So how does the T-Scan 10 actually measure the occlusion? So the sensor, this is the dental sensor, has 2,200 square force measures inside that are about a half a millimeter square. And between them runs conductive ink that is charged by the handle, which is plugged into your computer's USB. And so the sensor has electricity running through it. And as the patient bites on the matrix, the electricity is displaced. And it's displaced as it's happening, it's being recorded. Every sensor cell, that's what these measures are called, is being captured and streamed through the handle to the software. And it basically does this as I said, in 3,000ths of a second. So you get this dynamic video movie of electronic displacement where there's a lot of applied pressure. You get colors that are high, and the electricity displacement is very large. Where there's not so much displacement, you get low pressures and moderate pressures. And that's where the electricity displacement is not so great. And so this allows you to make really intelligent decisions about what to adjust. For example, if I wanted to treat this very high force, I would find it here at the mesiopalatal cusp of the upper left first molar, right? And then I don't have to guess. All I have to do is mark that area and adjust that known high force contact. So the T-scan allows you to make very targeted, accurate adjustments on specific contacts that are truly overloaded or time early. And that's the beauty of the data. It's dynamic data. So what it really allows you to do is capture differing functional movements from your patients that allow you to make very intelligent force and timing decisions about their occlusal problems. And it can also help you install prosthetic and implant dentistry, which we're going to talk about shortly. So here's a patient. This is a natural tooth patient. She's class 1 post-orthodontic. You can see she has abfractions and recession. She also has PMD muscular symptoms. So I'm going to record on her, and you'll see me doing it here. And this is in a seminar live, and you can hear me talking to her, but I'll sort of talk you through what's going on. So here you see I'm placing the sensor in her mouth, and up here is the T-scan. And we're also recording EMG at the same time, which is a great thing. You'll see when she bites down, it's real time. She's going to bite down, the forces rise. Now she's going to make an excursion to the right, and you can see the transitions occurring. And the EMG is being
She
recorded
has
at the same
premolar
time.
guidance. She has, she does reach her canine, but she has premolar guidance going to the right.
Right, she has premolar guidance, which I'm watching the screen and I can see what happens. So let's look at her data, right? So to give you some orientation, this is the 2D upper arch. We're looking at as if we were looking down on the maxillary teeth, the left side and the right side. This is the three-dimensional column view. This feature at the bottom is called the force versus time graph. And this actually shows you the entire recording from start to finish. So here's where I turned the recording on. Here's where she bit down. The black line is total force, so she's rising to full force. Here she wavers in her bite a little, and then at C, she makes a right excursion. So let's look at the closure. Now watch what you see in the closure. You see the time earliness of this extreme pressure on tooth number 15, or the number 27, and the late right side forces, and you see how they moved up and down? That's there's some friction there. And so this side is much earlier than this side. And although she has reasonable balance, it's only off by 8%, it's all concentrated posteriorly. And this is classic for how orthodontic patients finish orthodontics. Almost no force up front, extreme posterior force. For example, if you look at the last 4 teeth on both sides, they're making up almost 45% of the force. Here's 45% between the 2 molars on this side, and here it's 22 and 12, that's 36%, or 35%. So almost 70% of our forces are concentrated on the last 4 teeth. That's not good balance, right? You can see it's very clear. The other feature that's very interesting is the center of force. The center of force tracks the total force summation. So you can see she has actually pretty good balance, even though the timing is not so good. And at the end, the center of force favors the left side. So those are the important features in her closure. She's way too early on the left side with a very prominent force, and the right side is late, and there's almost no anterior contact, right? That's the basic setup of her bite. Now, if we look at her excursion, now she's going to go to the right. Now, what you'll see is how the center of force struggles to reach the anterior teeth, but you'll also see something else. Watch what you can't see with your eye. Watch the columns chop up and down. That's friction. Friction is occurring on the occlusal surface that you can't see with your eye. It's happening in hundredths of a second. And you see she struggles to get beyond the premolar, right? And the canine is in play, but it's not the guiding tooth, right? And if you watch it again, you'll see the center of force, how it first it goes left because the left side blocks her. And now it struggles to go to the right because the left side is in the way. The right posterior starts to rise in force. And now she's going to start to, again, struggle to get to the right. The premolar guidance takes over. And all of those transitions occur in basically from about 4.2 to 6.2 seconds. So that's about a 2-second recording that shows exactly why she has TMD. She's highly imbalanced posteriorly. She has extreme posterior occlusal forces, and then she can't make a free excursion because she has premolar guidance and blockages on the balancing and working side, right? So that's a diagnosis made in one recording, right? That's the beauty of the T-scan. Now, let's talk about some of these other things that are confounding all of your understanding of occlusion in the modern digital era. Everybody thinks their scanner gives them the occlusal forces with these color-coded occlusigrams, right? Again, what these are, so you understand, is contact proximity scales. So in other words, there's closeness where there's reddish colors in this version. And as you get through the greens and the blues, the areas of the teeth become further apart, right? But what's interesting about this whole thing is that people perceive these to be forces, but ask yourself logically, how do you capture scanner information? The patient's teeth are apart. Scanners take pictures of teeth that don't touch, right? And shooting from the side, putting them together, doesn't make you get forces from between the teeth. So iOS scanners cannot capture real contact impact pressures because the teeth are apart. You're taking pictures of teeth that don't touch, right? You can't get that information that you need, force, time, and pressure, unless you put something between the teeth. And you see the flexible, thin T-scan sensor is very acclimatable to this. It sort of conforms to the teeth after a few bites, and the mylar encasing holds up extremely well to multiple repetitive intercuspations. So this is how you capture between the tooth real contact pressures. So what's confounding you is these occlusograms, right? What they really are, as I said, is contact approximation and surface areas. It's not actual pressure. And so they say there's pressure, right? But look at what the scale's measured in. Microns. Microns is a distance. Pressure is measured in force per unit area, like newtons per square centimeter, right? Not microns, right? There is no pressure being generated in any of this. And to show you how flawed these occlusograms really are, a study was recently published last month, where a prime scan, the most accurate according to the literature scanner, was tested against T-scan data to see how well the scanners reproduced the depiction of pressure. And of course, if you look at this occlusogram, you see there's extreme contact intimacy on the right. That's all this red. And some contact intimacy on the left in the posterior palatal cusp of the last two molars. But there's only one area of high force, right? And one area of moderate force. And this is a real problem because if you believe, if you believe this information as being pressure, well, what are you going to adjust? You're going to adjust all these areas? That would not be good based on true pressure mapping, right? You can't use this information to adjust someone's bite. You might study the fact that they touch on this side better than they touch on this side, but it doesn't translate into pressure. Actually, this study found that prime scan dramatically overestimated the concept of pressure in this scale, right? Dramatically, and had a tremendous number of false positives. If you're interested in reading this, you can go to it's called the Journal of Advanced Dental Technologies and Techniques. It's an open access journal, and you can search this citation and you can see for yourself how much more accurate the T-scan is in giving you true impact pressures because you measure from between the teeth. You're not taking pictures of teeth that don't touch. Then you have the problem of what are you going to adjust? I asked you this before. Do you adjust only the blues? Do you adjust only the oranges? Are you going to adjust all of the oranges, all of the greens, right? It's a big problem. You don't have that problem with T-scan. T-scan shows you exactly where to adjust. It's just these two cusps, and maybe this contact right here, maybe, right? T-scan shows you exactly where the problem contacts are. Scanners can't do that for you. So don't be fooled by the scanner companies. Their contact approximation data is not force, time, and pressure. Okay, so that's a little bit of the introduction on what's available to you. Now let's talk about complications. So as you all probably know, implant complications are so frequent, despite all the advances in the digital workflow, that they actually outpace conventional dentistry. And we say things like, well, the systems are rigid and there's no periodontal ligament, but that's actually not totally the truth. That is an element that certainly magnifies the reality of having bad forces and poor timing on your restorations. But actually, the real reason that there are so many complications in implant dentistry is that the cases are installed with non-digital occlusal indicators that don't measure anything occlusal other than the size of the contacts. And we're going to talk about this in great detail, right? So here's just an example of one study that was published, an 8-year follow-up study on 114 full arch implant supported prostheses. Half of them broke. And if they break like this, as you all know, if you've had this happen, you can't repair this. I mean, you can mechanically try to repair it, but it doesn't repair. The only way to repair this is to make it a second one. And unfortunately, that's the reality of the modern dental materials. What's interesting about this study is once something broke, it broke again. So almost half of them, almost 26% suffered a second prosthetic complication at least more than once, right? So that's a significant problem. And I'm sure you've all seen that. Once one of these implant cases breaks, sure enough, it'll show up in your office again in pieces, right? So those are the kinds of complications that are mechanical breakage, mechanical issues with parts coming loose and screws unscrewing and things becoming uncemented. But there are also these complications which plague many dental offices.
I had a lot of dental treatment done about 2 years ago. I had some crowns and some overlays and inlays done on all quadrants of my teeth. And after that, my bite was just completely off. And I had a lot of pain in biting, a lot of heat and cold sensitivity, particularly cold sensitivity, a lot of difficulty relaxing my teeth and jaws, even just when I was not chewing, just in a regular, holding pattern. And agonized basically for 2 years, wondering what I could do. And I happened to come across Dr. Kirstein's information on the web and knew I had to get in here. And 1 week post-treatment, I feel as though my jaw has completely relaxed and has been allowed to come forward more. I was particularly feeling a lot of sensitivity on the left side, but it feels so much better now. Cold sensitivity has started to decrease. I'm much better able to chew harder foods, things like broccoli or carrots or things that have more snap to them, nuts in particular. Where before I really had to baby them and practically suck on them, now I can actually bite on them, which is just amazing to me. So I feel that there's just been a tremendous improvement.
So what treatments did you have after the crowns were made? You had the dentistry done. What did you try to do for help?
So actually I went back to the original dentist several times, and he would use the blue tapes and just try to grind down the teeth just from looking at the regular blue tapes. Like I said, I probably went back to him about 4 times, and I was classified as someone who had an extremely sensitive bite, which just annoyed me because I knew there was a lot more going on in my mouth than that statement. I felt as though I was sort of being dismissed a little bit. And then I tried 2 other dentists who were very sweet and tried to help me, but I just could not get the relief that I now feel from this procedure.
And did they use carbon paper only?
Yep, carbon paper only. There's no other.
So they didn't use computerized bite analysis?
No computerized bite analysis, no.
Those kinds of complications are so common. They could happen to any one of us because of this material, not the porcelain, the paper, right? This is why there are so many complications, because the paper doesn't measure what we need it to measure, and what you've been taught about it actually, as you're going to find out in the next few minutes, isn't true at all. And so this is the part of the presentation where if you want to move forward in occlusion, if you want to limit your complications, if you want to get better outcomes and shorten your treatment times, You have to face the truth that you're going to see in the next few minutes, and then move forward into using measurement technology to treat your patient's occlusions with. All right. First of all, the restorative process is a macro occlusion process, meaning the digital workflow makes teeth, right? It doesn't make the micro occlusion, it makes the macro occlusion, right? It makes the prostheses that bang into each other. And then at the end, we use an analog material that we believe we can read based on principles that you've been taught, which you're going to find out aren't true at all. And I want you to look at this picture because you have your perceptions about where the forces are, but we'll come back to this picture and we'll see if your perceptions were correct. What you really need to do is create a preservational micro occlusion when you deliver the macro occlusion. So the reality is all of the implant and prosthetic complications literature makes a very big assumption. It's actually a totally incorrect assumption. As I said, the systems are too rigid and the materials are too hard and there's no periodontal ligament. Well, yeah, that's all true in a way, but the wrong assumption is that the occlusal forces are being managed at insertion with traditional methods, when multiple studies show that articulating paper, occlusal wax, silicone implants, shim stock hold, and scanners do not measure occlusal forces in any quantifiable way. So we're using materials that show us contact locations and contact areas, but not contact forces, time, and pressure. And here, this is by far the best example I've ever come across. This was a patient in a seminar in California, 3 large marks on very healthy tooth structure, exposed dentin, paper marks surrounding the exposed dentin, and this is what it really looks like when you measure it with the T-scan. Extreme pressure destroyed the enamel. And why there's no ink on the exposed dentin is because, think about it logically, if the enamel can't survive, how can a piece of paper and ink survive, right? This is why you don't get marks on exposed dentin. The enamel is destroyed. The forces are too great. And here you see low forces with these 3 big marks, and that's why the tooth structure is so healthy. So these ideas which you've been taught, they're completely incorrect. Large dark marks are assumed to be high force. Small light marks are assumed to be low force. And widespread paper marks means you have simultaneous timing. And unfortunately, this is what you have to come to face if you want to move forward in occlusion in your life, no matter who you're learning occlusion from. None of that is true at all. None of it is true, right? It's what's been believed. It's what's been taught. So what is actually true? First, multiple mark sizes can represent a single load. What in simple terms, that means you can have a mark like this and a mark like this, and they can be made from the same force. The difference is the size of the contact. That's not force, that's area, right? Then you have the inverse of this. A single mark size can represent many loads. So you can have a mark like this one and a mark like this one, which are virtually the same, and they can be very different in force levels. And you'll see what I mean when I show you the research. This study, they used articulated casts, and what they did was they doubled and tripled the loads and marked the teeth with twice as much force, 3 times as much force. And what they found was the marks got smaller as the loads went up. Well, that makes sense. Paper it's just paper. It gets chopped up into little bits with more force being applied, right? This study is very interesting. It found that the largest mark in a quadrant was only the most forceful tooth of 36% of the time. So if you always choose the biggest mark to be the most forceful place, you're going to be wrong 64% of the time. That's not good. This study in 2021 showed that smaller markings or point markings were made from higher forces, while broader and plain markings were made from lower forces, right? And this is just what I showed you with that exposed dentin case, right? The paper marks can't survive when the force is too great. So the paper gets chopped up into smaller and smaller bits at higher and higher forces. So unfortunately, this method, the paper mark method, requires you to decide what to do. And this is what leads to the complications, because there's no quantifiable information here to make decisions about other than surface area. And surface area is in force. You just saw that in the scanner occlusogram. All that red surface area, which things were touching nicely, wasn't high force, right? So let me show you this study. And this is the most comprehensive study to date. 600 paper marks were made from 0 to 500 newtons every 50 newtons. And what they would do is they would mark the teeth at, let's say, 50 newtons, photograph the casts at a consistent distance, wipe off the ink, raise the load to 100 newtons, mark the teeth 5 times, 4 times, photograph the casts, wipe off the marks. They did this from 0 to 500 newtons. And each time they would photograph the cast, they found these 6 contacts on the top and these 6 contacts on the bottom were on every cast. So they only followed the ones that showed up on every cast. So for example, on some casts, some photographs didn't have these, for example, these anterior contacts. And so they only followed the ones that were on every cast. So here's what they found. If you take a given load, like 300 newtons, median human bite force, you can see there are small marks. This is mark size. This is force. There's small marks, medium-sized marks, medium big marks, and bigger marks. And every column has multiple mark sizes. So if we go to the most forceful one, 450 newtons, you see there are small marks, medium-sized marks, and big marks. And although the biggest mark is in the last column, there's also a very small mark that represents the same force. So what these ovals mean, and before I say that, next door is the same size mark, 50 newtons less. How would you distinguish these two loads? The mark size is the same. For example, here's 450 newtons, here's 400 newtons, here's 350 newtons, here's 300 newtons. They're all the same size mark, right? So this is a real problem. So what these vertical ovals mean is you can have a big mark, like the tallest one and the biggest one in this oval, and a small mark, and they can be made from the same load. The difference is not the load, it's the surface area. And that's what you have to come to face. Now, here are the lower teeth, lower cast. If you look at 300 newtons, it has the most marks of any column. Small, medium, large, larger, largest, right? These are all one load, but they're all extremely different sizes, right? Impossible to know what size correlates to what load, because right next door is the same size mark, 50 newtons less, and right next door is the same size mark, 50 newtons more. But if you look at the mark sizes horizontally, this is 400 pixels. Every single mark size, every single load was represented by this one mark size. So what that means is you can have lots of marks that are the same size. One can be 10 newtons, one can be 450 newtons. How are you going to know? You can't know. So what this study found was that large marks were only high force 14% of the time, and small marks were only light force 14% of the time. And that means if you choose by size, you're going to be wrong 86% of the time. And that's a real problem. And it's actually been studied. The uncomfortable truth is that 4 separate studies, these 4 studies here, show that dentists choose the wrong high force contacts 90% of the time or greater. And you say, no, that's not true. I never choose the wrong contact. Well, yes, you do actually. And here's an example of how it happens, right? Patient gets a new crown. They say it's high. So we go in and we mark it with carbon paper, and they tap, 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 and we choose the spot we think it is. And then the patient says, no, it's still high. We chose the wrong place. We didn't choose one where the patient says, yeah, that's better. It's not gone, but it's a lot better. And so when you choose and you get it's still high, you chose the wrong place. And this is so common, we think it's okay, but it's not okay. Because what happens is we grind the wrong places. We can destabilize someone's bite. We can cause them to develop TMD. We can cause the crown to be thinned out in the wrong places and leave bad forces on the crown that causes it to break. So when you look at these marks subjectively and don't have a qualifier like the T-scan data to show you what they mean, many incorrect contacts get adjusted. And this is a harsh reality that, again, we all need to face. So here's an example of that. This is a study that was done with 125 dentists. They were asked to choose the 2 highest force contacts in this picture. And essentially, this is replicating the idea of patient gets a new crown and they call up and they say, my bite's off since I got the new crown. I got to come back in. And you have to choose, right? What's the problem contact, right? And it doesn't mean it's on the crown. Sometimes we grind a crown too much and another tooth becomes high. So do it yourself. Which are the two highest force contacts between numbers 1 and number 9? And you have to do this in your office every day, right? And what you're doing is subjectively interpreting the way the marks look. You're not using any data to do that. The size of the marks may be useful. It may not be useful as you're finding out. So go ahead, choose two that you think they are, and let's see if you were right. Were you correct? Number 4 and number 9. And my guess is you weren't correct. And the reason I would say that is because these dentists who had 250 choices to make only chose 12 correct contacts out of 250. 95% of the dentist's choices were wrong. So the question is, what misled them, right? What misled them was, if you look at the first set of choices, they chose 6 and 5 the most. 6 is a dark mark, big mark. 5 is a dark, big mark, right? Not correct. Not correct at all. The second choice, they chose 8 dramatically. Well, 8 is a big dark mark right there. This is a huge problem for the patients because when we grind the wrong places, we can destabilize their bite. So the question is then, how does T-Scan 10 help you control occlusal complications? Well, it's actually been studied. This study was just published in 2024, and I won't show you the whole study, but I'll show you the real important information. So essentially, what T-Scan does is it provides occlusal force and timing control when the macro occlusion is being installed. So here's a perfect example of what goes on. This is the macro occlusion. That was an all-on-6 against an all-on-6. This is called the macro occlusion illusion. This is something you've seen in many lectures, the after slide with all the teeth touching and everybody believes that the occlusion is good. Unfortunately, that's not the case. It's an illusion. Let's see what it really looks like. Well, here's the T-Scan data of this case. There's an STL file of the prosthesis underneath. There are 3 implants under overload warning, which is another great feature of the T-Scan. Watch the timing of this. First, the anterior right is too early. Then the posterior right is too early. Then the middle of the right is next. And then the left is late. Now, watch the center of force. I'm going to play it again. First, it goes to the left. Then it goes down the right side. Then it goes across the midline. This is why things become loose and unscrew, because the prosthesis is going back and forth like this every time it's loaded, right? Now, you can take that information and turn it into something like this, where it's much more uniform. Look at the center of force. It quickly centers and it balances. And the forces are low to low moderate. Might be helpful to take a little bit off of that one place, which is the mesial of the 5-4 marginal ridge, right? Now, this is how the case goes home with simultaneous timing, ideal balance, and low forces throughout. That's a much more effective way to send the patient home. In other words, which one would you rather send home? The one that's timed poorly and toggles the prosthesis back and forth and unscrews the case, or one which quickly balances and seats the case every time the patient bites down, right? This is the beauty of using data and metrics, right? The balance here is off by 0.2%. Here, the balance is also close, but the timing is so dramatically better in this end result. Remember, this is an illusion, the macro occlusion illusion. It doesn't guarantee you the micro occlusion will be good, not at all, right? So in simple terms, what T-Scan does is explains to you which contacts you should treat and which ones you should leave alone. For example, in this case, if I want to balance this patient's bite, I have to adjust this place and maybe this place, and the rest of it I can leave alone because it all matches up. That green matches that green, all these light blues match up, right? So I'd only be adjusting here and here. Now, would you know that if you didn't have the T-Scan data, right? That's the real question to ask yourself. Would I have chosen those 2 places, right? Now, here's something many of you may have done. This is something that many continuums teach this idea that if you make all the marks the same size, you've balanced the bite on a splint. Well, it's definitely not the case. Here's this splint, right? the center of force goes left, then it comes back to the right. There's 5 or 6 uneven forces. The balance is off by 9+%, right? Watch it again. Left side early, right side late, center of force nowhere near the balance point. But you can take this, use this data, and turn it into something that's truly balanced. Look at the center of force. It comes right down the middle. Everything is low force. Balance is off by 0.4%, right? Now look at the paper marks, right? This is a false premise, believed, but not true, right? Broader marks, lower forces, just what you're seeing. What's interesting about this, the patient was watching the data on the screen, which is something that happens, and she saw the center of force and she asked, can you get this in the middle? Does it ever get in the middle? And I said to her, if we do a good job, it'll be right down the middle. And sure enough, there it is, right? So this is extremely controllable, but this is a misnomer, a belief system that's highly flawed. So something you, as I said, you have to come to face this if you want to move on in occlusion. And here's a perfect example of how misleading the paper marks are. The question is this good? There's an upper denture against a lower hybrid. Do we know if this is good? Do we know if this is balanced? Do we know if this is simultaneous? We really don't know, right? Now, what the T-scan shows us is there's extreme anterior pressure. And if I didn't have this information when I was delivering this case, all of that composite on this hybrid would be in my hand within 6 months' time, right? This is the beauty of having data, right? The T-scan guides the micro occlusion adjustments, right? It shows you where you need to lessen pressure, right? And this is how it plays out clinically. So here's an example of a problem patient. The patient got a crown installed on tooth number 13, and the day after, tooth number 11 began to bother him. And he went back to his dentist over 4 or 5 months many times, and the dentist wasn't able to resolve the problem. And finally, he was referred to me. The patient came in and said, I was told I have to see you because you have a computer and maybe you can figure out what's wrong. Well, this is what I saw the first day. This is tooth number 11 mesial, right? But this is what the T-scan showed us. Watch tooth number 11 outpace every other contact, right? And the dentist actually, he took out the crown before I saw the patient, not like the day before, but he thought he could resolve the problem by taking out the crown. So this is a temporary crown he had to place. So now he's into it for many visits and another crown at least. And what he couldn't see was how powerful tooth number 11 mesial was, right? He couldn't see that. You can't see it here, right? So the question becomes, what do I adjust? What should I treat? Well, you map the T-scan data to the paper marks. It's very simple, right? That's the mesial of 11. That's 12 palatal, right? This is an area of high force on the second molar on the left, right? But for my own purposes, I said, well, I'm going to use a thicker paper. I want to see if tooth number 11 will look any different. So I used the thicker paper, and all I got was lots of artifact, but I still got the same pinpoint high force contact. Now, look what happened to the anteriors with the thicker paper. Huge marks, but all low force. So the paper marks are going to mislead you. And you can't use size to guide you. And this is a big problem. And if you don't come to face this, you'll never move forward in occlusion. Dentistry will never move forward in occlusion if we don't face this, because it's not fair to the patients, right? Here we have extreme pressure. I turned it into this. Center of force in the middle, everything the same, low forces throughout, maybe take a little bit off of the palatal cusp of the first molar on the right. And the patient was stunned. He goes, you fixed this in one day. I've been going for months and months and months, and my dentist couldn't fix it. And the next question was, why doesn't everyone have one of these, right? And the real question is, why aren't we all using the T-scan? And some of that has to do with what you've learned from your occlusion educators. They may have told you things about the T-scan not being useful, or the sensor not being accurate, or the system being this, that, or the other thing. All of that is contrived drawbacks, right? This is the reality. You can fix things you can't not understand when you have data that measures force, time, and pressure, right? Those contrived drawbacks are political and emotional ways to keep people from adopting the benefits that this offers you and your patients. The patient was stunned that I could fix it in one day. A few more examples of how misleading paper marks are. Here's a great service, right? Implant overdentures, locator attachments. These things are like rocks, right? Here's the macro occlusion illusion. Here are some paper marks. Is this good? Is this not good? Can you tell? The question for you is, which side of the denture has more occlusal force? This is the patient's right, as you were looking at the patient. This is the patient's left, right? Can you tell? Let's see. There's dramatically more force on the side that has less ink, right? It's off 67 to 32, right? Look at the amount of ink. If you didn't have the T-scan, you'd be grinding over here, making this worse, right? This is a huge problem, right? But with the T-scan, you can accurately diagnose the occlusal forces, not misdiagnose the occlusal forces. Here's how it started. And this was in a training where I was in an office with a dentist teaching them how to use the T-scan. And this is what we corrected it to. Look how quickly the center of force comes to the middle. Look at the low force uniformity. The balance is hovering around 50-50, right? You could take a little bit off of these two contacts, but this is a far more improved outcome, right? And again, you couldn't tell this kind of distribution from the paper marks. A huge problem, right? So what does this all mean to your implant cases? It means that when you choose contacts by looking at them, time and force contact selection is going to be hit or miss. And that means destructive forces are left in place. And that means complications arise. That can be patients complaining about their bite and coming back many times. That can be pieces of porcelain chipping off. That can be screws coming loose, right? Instead, use data, right? And this is really good example of how misleading the paper marks are. Many of you probably thought there was high force on these two laterals, low force, right? There's high force here in this area. Now look at the next tooth. These two marks are exactly the same size. One is low force, one is high force. How would you ever know? And then if we come over here to the mesial of this premolar, look at the scratchy little marks. But that's actually very high force. Not as bad as red force, but very high force, right? Would you have known what to treat without the data? And the answer is absolutely not, right? And you would have chosen incorrectly, like the studies show. So here's a study that proves T-scan controls occlusal complications with implant dentistry. It was published in 2024. What this group of dentists did was every time someone came in for an implant installation, they would use articulating paper only. The next time, the next patient that came in, they would use T-scan and articulating paper. The following patient, they would change back to just articulating paper only. And the following patient, they would use T-scan and articulating paper. So they were alternating how they were installing the cases. And what was found was with T-scan, there were only 3 complications of these 163 units installed with T-scan and articulating paper. Less units were installed with articulating paper, and there were 10 times more complications, most of them being screw loosening. And as I showed you, how the center of force moves around the arch, that's why things come unscrewed, right? The forces are torquing the prostheses. So the complication rate for articulating paper only was 1 in 4. The T-scan was less than 2 in 100, right? That's dramatic. That's really dramatic. So this paper is also available at Advanced Dental Technologies and Techniques. It's, again, as I said, an open journal if you're interested in reading it. So what is the T-scan and articulating paper method? How does it work? So here's a beautiful all-on-6, somewhat destabilized in the mouth, patient having discomfort with it. When we first recorded it, we also marked the carbon paper with it. So here's the patient's right side in carbon paper, the patient's left side in carbon paper. There are 2 implants under overload warning. Let's see what it really shows. I'm just going to stop it right there. Would you have known by looking at this that this was so early and so forceful compared to the rest of the marks on this whole arch? And the answer is absolutely not. This is an extremely damaging contact, right? It's the first high force contact. It's right in this area. It's actually on this premolar. It's right here, right? And then after that, more anterior there's pressure, and then on the left side there's pressure. I'm sorry, on the right side there's pressure. So this basically loads on this side, and in those three places. And then what you do is you treat the high force and moderate force paper marks. You leave the low force ones alone. And this is a good example of how you do this. So this is the most facial buccal aspect of the paper mark grouping on tooth number 3. So that's going to be all through here. That's where we're going to treat it. We're not going to treat the lingual aspects. So we're not going to treat back here. Right? And then the next two teeth are low force. We're going to leave those alone, right? Whereas on this side, we're going to treat the pinks and the oranges, right? And then you make another movie right away, right? So here's the next movie. And what you can see is it isn't that much better. And that's the beauty of the T-scan. It shows you what it is, not what you wished it was, not what you hoped it was. It shows you that there's more to do. And it also shows you when it's corrected. So here's a really good example of how a dark mark is actually low force, right? So we wouldn't treat that, but we treat the canine. There's two moderately forceful areas. We treat the premolar. This is a really good example. Look at tooth number 13, mesial and palatal, right? Mesial and palatal, but the distal is low force. So we leave that alone. And so you become very selective about what you adjust, right? So here's a little later, we still have 3 implants under overload warning, so we aren't making that much progress, although the center of force, it's leaving the middle. It's favoring the patient's left side, which again, you cannot see any of this information in the paper marks. And then again, you continue on. And here's a really good example. Look at this mesiobuccal contact that's moderately high force. There's a very small paper mark there that most of us would just say, oh, that's an artifact. It doesn't exist, right? That's a huge problem. Because ink doesn't measure force, right? Ink does not measure force. And then if we look at tooth number 14, the most distal area is where the high force is, but more lingual and more mesial is all low force. So we would only be treating the most distal area. That's the beauty of having the data. So when you get to the end, and you've seen it now a number of times, the center of force is going to crawl down the middle, and everything is going to maintain itself as low to moderate force. Although this contact is a little too forceful. Again, the T-scan showing you could do a better job. So what we really have to do is take this area and smooth it out. See, there's a sharp shelf there on that contact. Sort of that marginal ridge has a dent in it, not a dent, but a depression and a sharp edge. That's why this area is high force. If we flatten that and round it, that will go down to moderate force. That's all done in one day. That's how you get to the end. So here's how it started. 3 implants under overload, a severe time prematurity with extreme force and late unevenness on the left and then on the right. Again, torquing the prosthesis, or everything being uniform, loading simultaneously, rising together. These colors are rising together, right? And they're staying low moderate, except for this one. Question is, which one would you rather send home? Right? That's really pretty clear. By sending the patient home with this, you control your complications. Okay, now, last few slides. So what do patients say about the T-scan? This is a young lady who just had her bite adjusted.
Okay, Rosemary, you just had your bite adjusted with the T-scan. So how did it change? What's different for you?
I cannot believe how drastic the change is. It feels so much more comfortable, and I'm just blown away by the difference and the progression as we went through the process and used the machine and just pinpointed different spots. It was just amazing. It's just amazing science, and I'm so grateful to be a patient today.
So patients are very impressed with the T-scan. They really are. And they often wonder why everyone doesn't have one. But what she said was really important. She said, we went through the process and we pinpointed certain spots. That's exactly what you just saw me do with that all-in-6 case. You pick the places that need to be treated, and those are the only ones you adjust. You don't say to yourself, oh, I think it's that one because it's dark ink, or that's a big force because there's a big mark. It doesn't work like that. As you can see, mark size has nothing to do with force. So this is one patient in a training. This is a totally different office. A dentist in Atlanta who's had me come and train. Here's a different patient's perspective.
And it was just really cool to watch all the colors and the quadrants.
Yeah.
And how things changed with each time. You ground a little bit down, you changed a little bit, at a time. And what, you did it like 3 times,
Yeah.
4 times? Yeah. And how it helped. I'm like, I totally feel the difference already.
What do you feel?
It just feels more even. It's like my teeth are hitting on both sides now, and I didn't even, it had been that way for so long.
Didn't even realize.
I didn't even realize that they were only hitting on one side because it had been that way for forever. Yeah, this feels better.
Good.
It's
So
gotta
you-
be easier.
And you like the software.
I do. It's really fascinating.
I think
So, you know, I mean, it's pretty cool.
Awesome.
Yeah.
Thank you.
you.
And not just because it's colorful and pretty.
It
I
is
mean,
colorful and
it's
pretty.
useful. You know, it's pretty
is.
useful.
It is.
Yeah, that's pretty cool.
It's
And-
very useful, right? Now, here are some things to show you a couple of examples of how powerful the T-scan is. This girl is about to drink ice water, and she has cold sensitive teeth. And you're going to see how difficult it is for her to drink the ice water. Then she's going to have her bite adjusted with the T-scan in the same visit. And she's going to drink all new fresh ice water. I would say the difference in time was like 45 minutes, maybe a half an hour to 45 minutes.
Take a mouthful of water, not just a little sip. Good. Swish, 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 swish. Okay, swallow. So rate that on a pain scale from 1 to 10, 10 being the worst, 1 being it's just cold.
It's probably a 7 or 8.
Okay,
It's pretty cold.
okay, all right, good.
Swishing wasn't easy.
Okay, so now she's going to have her bite adjusted in specific ways with the T-scan, new glass of ice water, same visit.
Swish, 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 swish. Swallow. Where would you put that on a 1 to 10 scale?
Like cold. Pain, like 2, 1.
Now we have a study of, it's down at the bottom, of 150 people doing the same exact thing. And how rapid their cold sensitivity goes away is dramatic when you use T-scan to control the occlusal forces and the timing. How about clenching and grinding? All right, people say you can't treat that. It's a central nervous system problem. Absolutely not true.
All the
T-scan
time,
treats it.
yeah.
You don't have it anymore.
And my jaw, like, I can move to the side, I think, because my jaw isn't so tight.
Did you hear that part? You can't clench.
Yeah, I don't clench at all.
You know, the thing is, well, Heidi said the same thing.
I know.
Carol said the
Oh,
same
really?
thing.
But they didn't
Nicole
have the
said the
tremors
same
that
thing,
you
yes.
did. They didn't have
Yeah,
the
mine was
shaking.
bad,
Yeah.
and it's,
And no sensitivity to cold. That's
Yeah.
amazing. Yes, so
and
they
no,
will send this.
I can't believe no
They will send this
sensitivity.
video to Dr.
Kirsty,
I am shocked about the no sensitivity.
So there you've heard from 3 or 4 different patients in this presentation how their cold sensitivity went away. Right? This is a 7-day follow-up. And you heard the doctor say, Carol said the same thing, and someone else said the same thing. All of the 3 patients that were in the training, 3 of 6 that he mentioned, they stopped clenching and grinding within 7 days. And they're not wearing night guards, they're not having to sleep with an appliance, no NTIs, no Botox, no appliances, no orthotics. It's just high precision occlusal therapy that changes all these things dramatically. Right? Now, here's the last thing I'm going to show you. We've discovered in the last few years that we can actually open the airway physiologically without an appliance using T-scan. And again, in specific ways. So here's a patient's airway shot on CT. This is the reconstruction. The constriction zone is in green. The lighter colors are constricted. The darker colors are more, or let's say more open airway. The total volume is 265.7 square millimeters of airway volume. 30 days later, look at the airway. It's much wider. It grew a section, right? It's all dark blue with a very small area of green, right? And it gained 50 square millimeters of airway volume. And the beauty of this is it isn't an appliance-based thing. You know, if you give someone a snore guard and it opens their airway, as soon as they take it out, their airway collapses back to the shape it was. This is not with an orthotic. This is by changing the occlusion. If you want to read about that, this chapter, Airway Volume Changes Detected by CBCT, by Dr. Atul Satur, is in the T-scan Research Encyclopedia. It's an amazing chapter, all about airway physiology. But this is one example. Here's another example. Look at this funnel-shaped airway. It gets smaller as you get to the bottom. And look at how the constriction gets worse as the colors get warmer and warmer, right? 30 days later, look at the airway. It's parallel walled. It's not funneled anymore. It grew a section. And look at the constriction. It's only moderately constricted all through the airway. Again, gaining 57 square millimeters of airway volume. So this is the power of the T-scan, right? This is something that you cannot do things like I'm showing you without measuring time, force, pressure, and seeing the interface of the teeth engaging each other the way the T-scan can measure. So if you're interested in learning more, there's a 2-day course that myself and Dr. Ben Sutter give. The next one is May 16th and 17th, or September 26th and 27th at UNLV Dental School. We treat patients live in front of the group, and we show you how to do T-scan and disclusion time reduction. And if you're interested, you can go to this website and you can get information on course and the time, the dates, etc., the costs. And I think you can sign up there as well for sure. The other way for you to learn, if you have a T-scan in your office and you struggle with it, or you're not sure how to use it, or you certainly aren't getting the results I'm showing you, you need to learn how to use it. And the only way you can do that is chairside training. You have to learn how to take the data well, how to interpret the data, and then how to use the data to guide what you change. So you can use the T-scan in training on implants, post-ortho with TMD patients. You can adjust existing prosthetic patients that already have their teeth. They don't have to be newly installed cases. And what you learn is how to use the T-scan at the chair as you treat patients live. And so this is the best way to learn. There's no question about that. If you want to hear what, if you want to hear what doctors have to say, you can go to my website. If you're interested in talking to me about in-office training, you can email me at this email address, or you can call me at my phone. This is my website is here, drrobertkirsting.com, but this is where you would reach me. And this is by far the most effective way to learn T-scan skills. No question, hands down. Now, last thing, from a practice management standpoint, what the T-scan 10 translates into for you as a dentist on a day-to-day basis is, first, you have increased revenue because you have far less fractures like this. You have less unscrewing of cases. And the most important thing is you have less people coming back complaining about their bite after you install their case. And that's because you have improved outcomes. You use data to install the cases with, and then you have control over the outcome, measurable control, and that translates into improved patient comfort.
Even.
And what else?
More adjusted.
And how does it fit?
Like a glove.
And before?
It seemed right, but it wasn't.
Exactly.
Exactly. So thank you for your time and your attention. I'm very honored that TechScan asked me to present tonight to all of you, and I look forward to taking your questions. And certainly, if I can't answer them all, I will answer them with the help of Diana. She'll provide me with questions, and I can send back answers appropriately that she can share with all of you. So thank you for your time and attention. I'm going to leave the PowerPoint and go back to Zoom.
Right. That was excellent, Dr. Kirstein. Really appreciate it. I mean, your depth of knowledge, not to mention your passion around the T-scan and occlusal analysis, it just never ceases to amaze or impress me. So really, thank you very much. It was really great. So yeah, so we really would like to open it up to some questions. So yeah, so please feel free to put some questions in the Q&A, and we'll answer that. Definitely a lot of compliments on great job, very informative, learned a lot, so that's always great to hear. There are, let's see, let me go back, a couple of questions around training. So let's see, one,
Okay.
what would you say is I guess this is hard to, what's a typical learning curve look like in terms of time or number of patients treated?
Well, it's a very good question. So to learn T-scan, you have to learn three things. You have to learn to record data properly from the patient, which is a skill set that doesn't come to anyone who buys a T-scan because you have to learn how to manage the data and get the appropriate data from the patient. You also have to manage the patient to make the right movements, and that's certainly something that you learn in training, chairside training. The second element is you have to understand the data, how to analyze it, and then how to know what parts of it matter in terms of making changes. And then the third part is to learn how to transfer that information, that decision-making process, to the teeth. And so that's really the learning curve. Is 3 different things to learn. And there's no question that you can learn to record over Zoom. Like I'll often do a Zoom recording training session for someone. And what we do with that is they have a staff member be a patient, and we go through the whole recording process on them, teach them how to do a T-scan occlusal exam. And that gives them a start in getting good data. Then from there, the next phase is chairside training, because there is no real good way to learn how to be a T-scan clinician didactically. Like, you can read the T-scan encyclopedia and learn a tremendous amount, but it doesn't make you a chairside user. And that's the skill set, is to develop the chairside skills. It's just like learning to do a crown prep. I'm a prosthodontist. The first crown preps I drilled as a dental student, I destroyed the ivorine. It took me, months to be able to drill a good crown prep on a fake tooth. So chairside skills are, the only way you learn them is at the chair. So the learning curve can be greatly sped up by having chairside training, no question.
All right, great answer. Thank you. Yeah, and I'm going to add into that on just behalf of TechScan as far as training. When you do purchase a T-scan, there is a certain amount and level of introductory training that comes with a T-scan that is typically done with the account representative that you purchase the T-scan from. There's also an extensive library of training videos that we've developed over the years. So there's a lot of those resources to kind of get you going initially, and then certainly progress to some more advanced training, which we kind of recommend.
Yes.
Let's see, there's questions around the sensors. How long do the sensors last? And can you use the same, bite plate on multiple patients? I'm sure that referring to the sensors.
Well, also a very good question. So I addressed it somewhat in the early part of the presentation. So the T-scan sensor can be crushed between teeth 20 to 24 times and give you very repetitive data. So if you use it only a few times on a single patient, you can clean it off and use it on that same patient at a subsequent appointment. But you can't use it on different patients. If Mrs. Smith comes in for a consultation and I make 3 or 4 movies to find out what's wrong with her bite, and then she comes back to be treated in a week, I can take that same sensor and use it to treat her. But I'm not going to use it on Mr. Jones, right? So I can clean it off. The Mylar is easy to clean off with chlorhexidine or with alcohol. The sensor, sensor support, dropped a few things. I think my pen fell off. These sensor supports are sterilizable or cold sterilizable. They're hot sterilizable. So you can clean those very well. And the sensors, they're flexible, Mylar. Let's have to hold it in the right place. My blurred background, maybe I'll put it next to me. Yeah, I can't see it. They're hold up extremely well, but they're not meant to be used between patients, only with the same patient. And you certainly can use a single sensor to treat someone. For example, if we treat someone's bite and fix their cold sensitivity, we would use one sensor and then we would throw that one away and start the next session, a follow-up session with a new sensor for that person.
All right, excellent. Thank you. Let's see, here's a good one. What do you suspect is actually increasing the size of the airway after DTR treatments?
Also a very good question. So most of us don't understand, and this is not a criticism, it's just things that haven't been taught to all of us, the neurophysiology of occlusion. And in simple terms, the posterior pulps and PDLs travel directly into the brain. They're the only peripheral nervous system entity that travels directly into the brain in your entire human body. And in the center of the brain, they talk to systems that control swallowing, breathing, and airway control. And the reason for that is, think about it logically. When you go and eat something, you chew, you suddenly chewing, then you're suddenly swallowing, and you're breathing, and the food doesn't go down into your lungs, and it goes down into your stomach. And that's all modulated by the tooth contacts that are going on during chewing, swallowing. And so your brain controls all of that for you because of the pulpal and PDL innervation that controls the muscles associated with mastication and swallowing. And so when you use your teeth for many years and they tighten up your airway, they tighten up your jaw muscles, you may or may not experience symptoms. You don't necessarily know that. But if you have a compressed airway and you have excessive posterior tooth contact in chewing motions, excursions mostly, you tighten up those muscles. And many TMD patients will tell the doctor that they feel tension in their throat is tight as part of their condition. And when they get the T-scan guided correction, the muscles of mastication relax, which is why TMD symptoms go away. It's why their throat muscles relax, which is the swallow mechanism, which is what the teeth control. And so the airway opens because the pharyngeal muscles are relaxed from being in a contracted state. And it's all because of the neurophysiology of the occlusion. So this is why it's such a great correction. We reverse the tension that's in those muscles, in many muscles, actually, muscles of mastication plus the swallowing muscles. And that opens the airway in a permanent way. And you don't have to wear anything, take anything, see anybody. You don't have to go to a sleep lab. You don't have to, wear a sleep thing. You just have to have your bite corrected, because teeth are the primary driver of so many of these problems that you see every day. And airway is just one that we've recently been seeing responds extremely well to T-scan guided corrections.
Interesting. Thank you. All right. Here's one good one. Let's see. We are a teaching hospital and would like to arrange a training for faculty. They have a T-scan. How can we go about arranging that? And would a single session be enough? Sounds like an ideal question for you, Dr. Kirstein, when you spoke about your.
Well, usually, just to sort of simply answer, a single session is good for a single doctor, right? It's one-on-one training. So group training can also be arranged, but the dentists that are learning should be treating patients. So if you want to have a group training, there have to be more than one doctor treating patients. You can have a group training that's didactic. You can have a group training that's academic. But if you want to have patient training at your hospital, then you'd want to have at least, a few of the treating doctors be learning at the same time. And that can be done, by having 2 or 3 operatories with a few doctors learning simultaneously. So it's very doable. The way you would set it up is to reach out to my contact information, which was on the screen. I can should I put it up again, Diana?
Yeah, that might be a good idea. Why don't you do that? I'll look at through the other questions and see if
let's see, share.
Yeah, I think I'll just speak to, there's always questions regarding cost and price and things like that. And I really recommend that those are, and prefer that those are answered by, one of our local sales reps. Depends on, there are different, there's 2 different versions of the T-scan, which we didn't go into great detail on. So there's different price points, and those are best answered by your sales rep. So we can get you in touch with that person in your area.
This is where you would reach me by email, or you can call me directly by phone if you're interested in talking about training, or you have questions that you'd like to just discuss with me directly. I'm always available as a resource for anyone interested in learning, measured digital occlusion.
All right, I think we are coming up. We've kept people a few minutes late. We had great attendance and some excellent questions. So really appreciate everyone's time. And again, thank you, Dr. Kirstein. That was really very informative and very worthwhile. topic, and we really appreciate your time. So thank you everyone for attending, and enjoy the rest of your evening. Thank you. Bye.
Thank you, everyone. Appreciate you taking the time. And thank you, TechScan.
Yeah,
And you,
thank you.
Diana, as well. Thank you very much for your help.
All right. Night.
Good night.